Welcome to your first new lesson of the 2020 school year. We're going to start with gas laws. And in order to understand gas laws, the first thing we need to do is understand what we mean by this theory called kinetic molecular theory. This theory is really quite interesting because it's based on four postulates. All four of those postulates can be refuted to some extent. So let's look and see what those are. So kinetic molecular theory allows us to describe the behavior of gases at the nanoscopic 1/1000th of a meter level. It's based in four postulates or assumptions. And as I've already mentioned, we can find evidence to refute all four of those postulates. First one is the postulate that particles contained in a gas are so small we can assume the volume of each particle is zero. Well, here's evidence to refute that right off the bat. Here's a graphic of your noble gases. We know for a fact that the volume increases as you go from helium to radon. So we know that they all have different volumes. And so possibly the volume of those gases could impact how those gases behave. Here's your second postulate. Gas particles are constantly moving in straight lines, but random directions. Here's some evidence to refute that. It's mostly true, but even gas particles moving at a high rate of speed are affected somehow by gravity. Even if the initial velocity of those particles is so incredibly high, they will travel in a straight line almost infinitely. At some point, gravity will take over and curve their trajectory. So partially refuted, but we can still assume that those gas particles fall in a straight line. Let's see what else we have. Postulate number 3. Postulate number 3. Gas particles undergo elastic collisions with each other and the walls of the container. No kinetic energy would be lost. Well, we also know that gas particles, just like molecules, contain intermolecular forces that play a role in attracting atoms and molecules to each other. So if they have a role of attracting those atoms and molecules to each other, those collisions can't be perfectly elastic because energy is going to be transferred from one of the particles to the other. We can use the same statement to refute the fourth postulate that gas particles exert no force of attraction on other gases. Again, we've got intermolecular forces. We know that the larger the atom is, the stronger the London dispersion forces inside, or van der Waals forces inside of those gas particles. So we know that there's a force exerted because each molecule or each atom will have its own force of gravity. So we can refute that one as well. So here's what we're left with. We're left with the fact that we are basing kinetic molecular theory off of these four postulates, and those four postulates are going to drive our next 6 gas laws. So how can they derive those next 6 gas laws when we can refute all 4 postulates? And this is my connection to your TOK. So if each of those postulates can be refuted on some level, why do these assumptions lead to a theory that can describe, and we have evidence that it describes the behavior of most gases at moderate, there's a key phrase, moderate temperatures and pressures. At the bottom of this discussion post, I'd like you to put your best thoughts about that question. All right, so that ends lesson 1, kinetic molecular theory. After you enter that discussion post, move on to the next lesson, which is going to be Avogadro's law. Thank you.